A fantastic day. As promised, I will be going through drawing inequalities on a graph for both IG and A level. Now, it's important that we get this topic correct because the examiners love this topic, and due to most of the examining reports that come after past papers, most examiners say that this is the hardest thing, and that therefore, if something's very, very hard, they tend to repeat it over and over again in every exam, knowing that students are just ignoring this question or most likely being taught in a method where it's difficult to learn. So I'll try my best to simplify this topic for you so that you gain those marks. So the question is as follows. These inequalities merge at one point or cross all at one point where we have a region where it satisfies all of these inequalities. Something to point out, I always tell my students this, that if you have x equals or y equals, if you have x equals, your ruler is always at 90 degrees, okay, always at 90 degrees. And if you have y equals, your ruler would always be at 0 degrees or at 180. And I'll show you what that means. So starting the first one, it says y is greater than -4. So I get my ruler, and also it's very important to know, if you have a sign like this, it's always going to be a dotted line. Okay, if you have a sign with equals to, it's going to be a bold line, so non-dotted, a normal line. Okay, so let's do this. So y is greater than -4. So I get my ruler, and I line it up. We said that y will be basically 0 degrees. I grab it and I put it at -4, which is about there. Okay. Then I take a dotted line. Make sure it's a nice color so the examiners can see it properly, or make your dotted line nice and thick with your pencil so the examiners can see. So it's done. Next one is x is greater than 2. So x is less than 2. So when x is less than 2, our y is going to be at, our ruler would be at 90 degrees. So I grab my ruler, I put it at 90. So we're getting very close. And we're looking at 2. So we go to a 2 on the x-axis, and also I'm going to change my color and also jot it down. I'm using red here just for you so you can see it clearly. Sorry. Okay, so now we have to do the other one, which is going to be the following. So it says that y is less than 2x plus 1. So y is less than 2x plus 1. And what we do here is always plot the y-intercept. So the y-intercept would be 0, 1. And I got 1 from here. So 0, 1 would look like here. Then I choose any value. So let's say x equals 1. So y is equals to 2 lots of x, which is 1. 2 times 1 plus 1. And then y therefore equals to 3. So my coordinate I'm going to plot is 1, 3. Okay, 1, 3. And 1, 3 is here. I only need 2 points, okay, because it's going to be a straight line. Straight line, you need 2 points is enough. So I line it up. Obviously you have a physical ruler, so it's much easier for you to do that. So if mine is not that accurate, and again it's a dotted line because it is less than, not equal to. Okay, so now we've got a region. You clearly can see this question is quite straightforward to know where the region is going to be, because there's only one region. Okay, so it's going to be this triangle in the center. Now, how do I know 100% that it's this triangle? So what I do is I tell my students, choose any point on this triangle in this space, and never choose a point on the line, because this is less than, it's not equal to, so you can't choose a point on the line. So choose the easiest point. I tend to choose 1, 1, okay, and I put my test would be for 1, 1, okay, for 1, 1. Now 1, 1, I have to go through the inequalities and test them. So let's start with the first one. So my x-axis and y-axis is here. It says that the y value in the point has to be greater than -4. My y value is 1, therefore it is greater than -4. 1 is larger than -4, so it ticks off that. situation. Next one, it says the x value is less than 2. Our x value is 1, okay, and that is definitely less than 2. That definitely matches the coefficient. Now it says last but not least, y is less than 2 lots of 1, which is our x value, plus 1. Our y value is 1, so 1 is less than 3, and that is definitely true. So my region is all this triangle in the center and all this stuff in the center between the lines, and they tend to tell you label your region R, shade the region, and label the region R. So that's what exactly I'll be doing. I'll label this R. So the region is all of this enclosed in this triangle. So again, the first question, if you don't really understand it, the second question would absolutely be much easier. So let's move to this question now, right here. So the difference between this question now, guys, is that here we have equal to. And we said in the previous question, if we have something equal to, we'll have a bold line. So again, we have a similar situation. We have x is something 2. We said if x is equals to or y is equals to, y will always be 90 degrees. Sorry, y would always be 0 degrees / 180. And x would be definitely 90 degrees. So x is greater than or equal to 2. So let's go to get our ruler. Let's grab our ruler, which is about there. And we go to the y value, is basically 180 degrees of 0 degrees. So we go put our ruler on 0 degrees and go to 2, and there's going to be our line. But this time it's not going to be a dotted line, it will be a bold line. And what I mean by a bold line is it's just going to be a solid line like this, a normal line. Next thing, it says that y is greater than negative 1. So y is greater than 1. So I go to 1 again, that will be on, now it's going to be 90 degrees, because we're talking about x. So put it at 90 degrees. There we go. And go to 1, and again bold that line. Bold that line. So now we've done that. So now it says that x plus y is greater, sorry, x plus y is less than 6. Now we can't really plot something like x and y. We have to change it in the form of y is equals to mx plus c. So we can plot the c-intercept, or y-intercept, and then we sort it. So we'll rearrange this, so we'll have y is 6 take away x. So I shifted the x there by subtracting it. So now we have this situation. We say the following. We say that we know that it's going to cross at 6, because actually if you rewrite the formula rewrite the equation into this, we'll rewrite it as negative x plus 6. Okay, now it's in this format. Our c is going to be 6. That's therefore our point will be 0, 6 straight away, because that's where it crosses the y-axis. Then we choose any point. So let us use x equals, for example, 1. So y is equals to minus 1 plus 6 is equals to 5. The point that we're going to have is going to be negative 1, 5. Obviously negative 1, you don't have a negative 1 on this side, but we'll use, obviously we use positive 1. The point will be positive 1, my mistake there, 1, 5. And 1, 5 would be about there. So now grabbing the ruler, we line it the points up. Line the ruler, we point the points up to here. Okay, and we just use a bold line to do that for us. So now we can see where all the regions meet. In this question again, it's very easy. We can see the triangle is a small triangle here, but we have to test it. So I'll choose this time 2, 2, 3, 2, 3, 2, 3 is here. So the test point today that we're going to do for this question will be 2, 3. Okay, 2, 3. So now let's say, so our x value is 2 and our y value is 3. It says that our x value is greater than 2 or equal to. So it's greater or equal to 2, that is true. Next one, it says that y value is greater or equal to 1. So 3 is greater than or equal to 1, yes. Then it says adding the x and y will give you something less than 6. So 2 plus 3 is definitely less than 6, and that is true. So our region definitely is going to be here. So that's our region. And we'll label that R. And that's region R. So again, it's very, very similar procedures. Did not take that long to do it, and we're here. So now let's look at a different question where we require more work. For example, this question, let's say a more difficult one, the bottom one here, where we have fractions and stuff. Okay, so the question is as follows. X is less than 4, 2x plus y, again, should be becoming very useful now, easy. So we said that if we have something like x is equals to y is equals to, the x is going to be 90 degrees and y is going to be 0 degrees. So grab a ruler. Let's do this one. Let's find where x is less than 4. So put your ruler at 90 degrees and put it at less than 4. And again, this is going to be a dotted line, because clearly we know, because it's not equal to. Fantastic. Straight to the point. Well done if you got this done. Next thing is going to be the following of 2x plus y less than 6. So, or greater than 6, sorry. So 2x plus y, we said that we have to rearrange it, so it becomes y mx plus c. Therefore, it will look like the following. So y is equals to minus 2x plus 6. We can get 6 straight away, so it's going to be 0, 6 away. It cuts the y-axis, so 0, 6 is here. Then we put any value for x. Let's say let x equals 1. So minus 2 times 1 plus 6 gives me a y value of what? A y value, sorry, a y value of 4. So it would be 1, 4 would be the next value. So now we grab our ruler and then we line up the 2 points. Again, you can choose any value that you want. Okay, but this time we chose that value. Again, obviously my drawing is not going to be that more accurate, as it's I'm using a computer, and I hope you appreciate that. There we go. Sorry. Now we've done this, the last portion we need to do is plot this line, y a third x. If we have something like that, where we have it in the form of y equals mx, you can always add a 0 here. Okay, to remind you that it crosses at 0. It crosses at 0. 0 is about here. Then we get again a value for x. Let's say x is equals to, I'm going to use 3 this time. Why am I using 3? Because it will give me a whole number. Because 3 times a third is actually 1. Okay, so the answer would be 3, 1 would be my point. So 3, 1 is here. And again, this is going to be a dotted line. Drawing this line, and it goes on forever. Then we've drawn all of them, so now we are looking for the region. In this question, you have 2 regions. You've got the region at the bottom, okay, and you've got a region at the top. Here, you've got a region, and you've got a region here as well. So in this situation, here is where testing plays a major role. So imagine it was, for example, this region here. So I choose the point 3, 4. Okay, I choose this point. So my test point will be 3, 4, and it's a matter of testing it. So it says my x value and y value. So it says my x value is less than 4. That is true, because x is 3 and 3 is less than 4. Then it says if I take my x value, I times it by 2, which is 2 times 3, and I add 4, it will be greater than 6. 2 times 3 is 6. 6 plus 4 is 10. 10 is greater than 6. So it meets that criteria and that criteria. Last but not least, it says that the y value 4 is greater than 1/3 times 3. And therefore 4 is greater than 1. So it's true. So the region only is at the top. So it's basically this region. And there. So that region here is definitely going to be the region R. So that is how we do this question. We are going to look at one final question because this video is getting a bit long, but obviously if you're happy with it, you're happy with it. If you're not, please keep watching. If you got to this stage, fantastic. You clearly, you're doing fantastic, and keep it up. So again, here we have y is greater than 1. We get our ruler, we go to 1, and we draw a dotted line at 0 degrees. I don't know why I just did a 360 there. Then it says again x plus y is less than 5. So we rearrange it. So x plus y is less than 5. We rearrange it so it's y is less than minus x plus 5. So it crosses at 5. So we put a point there. We need another point as well. So let's say x is equals to 1. So y is going to be equals to 1 plus 5, which is 6. Minus 1 plus 5, which is 4. We got a negative there. That'll be 1 and 4. So we have a negative gradient 1 and 4, so it's going to be there. We can line up the points now. So lining up the points. Last but not least, it's going to be 2x, so y is greater than 2x, so y is greater than 2x, therefore that will be the following. So we said that if we don't have a value here and we have y is equals to mx, it's okay to add a 0. So our point will start from here, and then we choose any value for y. So we choose x equals 1, so y times 2 times 1 gives me y is 2, so my point will be 1, 2, and 1, 2 is here. And again, these are all dotted. And shoot the line. Okay, so we've got the line there. We can see now there's another 2 regions. There's a region on this side and there's a region in the center. Let's try the region in the center because it looks like it's going to be it. So it's going to be, let's take 2, 2 for testing. So 2, 2. Our x value and y value. So that means therefore we can say that the first situation is that y is greater than 1, 2 is greater than 1, that passes the test. Then it says if you add x plus y, so 2 plus 2, is it going to be greater than 5, less than 5? Yes, it is. 2 plus 2 is less than 5. Then it says that the y is greater than 2 lots of x. So 2 lots of x is 2 and y is 2. 2 is not greater than 4. So it can't be this region. This region does not satisfy the last one. Let's try, for example, 1, 3. Let's try this region here. So let's try this again. Let's rub this out and put a different value. Again, sometimes you have to just try it. Sometimes you're lucky you get it first time, and sometimes you get it after. So x plus y, xy there. Is that y is y is greater than 1. Y is 3, and that is definitely greater than 1. Fantastic. X plus y is 5, so that means 1 plus 3 is less than 5. Fantastic. That passes the test. The last one is that y is less than 2 lots of x. Y is 3, and x is 2 times 1. Definitely 3 is let's see that. So 2 times 1. So y is greater than. So 3 is definitely greater than 2. The region actually is on this side. All this is the region, rather than the small triangle in the center. That is definitely the region. So, fantastic. I hope this helped you with linear solving. The next part would be for things like quadratics, where just for AS students, and again, anything with quadratics follows the same procedure.